Okay, this is the P2 paper from January 2021. This is question number 10, the last question on the paper. And if we look at it, we can see it's quite a long question. It's actually a modelling with series question, and we're going to have some work on arithmetic sequences for part A, on geometric sequences for part B. But mainly it's a modelling question. So let's have a look at it and we'll see how we get on with it. So it says, in this question, you must show detailed reasoning. All right, fair enough. Let's break it down. Owen wants to train for 12 weeks in preparation for running a marathon. During the 12-week period, he will run every Sunday and Wednesday. Right, okay. On Sunday, week 1, he will run 15. Sunday in week 12, he'll run 37. He considers two different 12-week training plans. In training plan A, he's going to increase the distance by the same amount. So that's going to be an arithmetic progression. So if we just look at A, for example, he's starting off at 15. He's going to end up getting to 37 there. And in order to do all that, what he's going to be doing is adding on D each time. Common difference, the same amount, to end up with that scenario. In training plan P, he will increase the distance he runs by the same percentage here. So this time, again, we're still getting from 15 to 37 here, but we're basically going to be timesing by 1.01, 1.01, 1.0. We're going to be timesing by R each time. So that's going to be a geometric progression. Okay. You could almost stop there and actually just get going with it, but let's just read the rest of it. So it says for A, calculate the distance he's going to run in week 5. For B, calculate the distance he's going to run in week 5. Okay, so it's the same style of question. For the rest of the question, it says Owen will also run a fixed distance X kilometres each Wednesday over the 12-week period, blah, 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 blah. So just in reading that bit, because to start with I was a bit confused, why Sundays and Wednesdays? So what we're doing for parts A and B, we're only considering the Sundays. This is going to be an arithmetic progression. This is going to be a geometric progression. We'll worry about the rest of it when we get there. So in terms of me sort of modelling the answer to you, what I almost do now is now I've read through all that, I say, right, okay, let's read through this again, but just thinking for part A, this is an arithmetic sequence. So where's my A, where's my N, where's my D? Am I trying to find nth term, A plus N minus 1D? Am I trying to find the sum of n terms, Sn equals n over 2, 2A plus n minus 1D? Break it down now and actually say, I'm only interested in, there's a lot of waffle here, I'm only interested in the information that's going to give me access to the question. So for part A, as we say, I mean, if you want to write a little sort of diagram up here to just make it easier for you as to what we're trying to do, that's what we're trying to do. We're starting off at 15, and by the time, that's in week 1, and by the time we get up to week 12 here, we're at 37. So that now looks a lot easier to me to try and work with. I'm saying A is equal to 15. I'm saying that the 12th term is 37. So 12th term equals 37. And basically what I'm trying to do is to work out what D is equal to, what the common difference is, what I'm adding on each time. So if I say this is an nth arithmetic progression, nth term is equal to A plus N minus 1D. Hopefully you're all aware of all the different formulae for this topic. So the nth term is equal to A plus N minus 1D. Well, in this case, N is equal to 12. Okay, so for the 12th term, I know it's A plus N minus 1D, and I also know it's 37. So 37 is equal to A, 15, plus N minus 1D, N is 12, so plus 11D. Oh, that's easy. So out of some really quite complicated modelling part to it, the rest of it then should work out to be nice and easy here. So 37 take away 15 is equal to 11D, 22 is 11, oh, that's an absolute relief. Okay, D works out to be equal to 2 each time. Yeah, well, I'm hoping I haven't made any mistakes with that. What was the question asking me? The question was saying, how far does he run in week 5? So in week 5, if we're going through here, week 5 will just be the 5th week. So it's going to be the 5th term when we're actually doing this. So you could do it by my diagram, but let's stick to the proper maths. I want the 5th term for the 5th week. So that's A plus 4D, and we know A and D now. So that's 15 plus 4 lots of 2. Sorry, 15 plus 4 lots of 2, 15 plus 8, 23 kilometres. Now, if you had time and you were a little bit panicky about this one, you could actually go through and put in 15, 17, 9, and just keep going through to see that it all works. But I certainly won't waste any time with that. I'll just move on to the next part. So part B says, in the training plan, instead of it being that he's adding on D each time, now he's multiplying by a percentage. So let's just make sure we're happy with what's happening here then. So part B. So what we're now doing is, again, we're saying 15 for week 1. We're saying 37 for week 12. And what we're doing each time is multiplying by, if we're adding a percentage, say that it was 8%. If you were adding on 8% each time, then you're actually multiplying by 1.08, aren't you? And then the next one by 1.08 and the next one by 1.08. That's just IGCSE work. So here in this particular one, I've got that A is equal to 15. I've got that the 12th term is equal to 37 again, but the 12th term this time is AR to the n minus 1 for a geometric series. So I'm going to try and work out what R is. So 37 is equal to 15 R to the 12 minus 1 to R to the 11. So I'm going to get that R to the 11 is equal to 37 over 15. Wow, okay, all right then. So R is going to be the 11th root of that. I might write that down like that. The 11th root of 37 over 15 on your calculator. In other words, 37 over 15 to the 1 over 11. That's the same thing there, and see what that works out to be. So if you plug that in, apparently it works out to be 1.0855. So if we were interested in, the percentage is 8.55 there, but that's not what we're asked for. Again, just like last time, yeah, I've worked out R, but I want the 5th term. So if I want the 5th term, sorry, just going back for the understanding here, what we're saying is, if I do 15, if I times that by 1.0855, I'll get the next term, timesing that by 1.0855, and continuing. If I did it 12 times, I'd eventually get to there. But we're going to use our geometric progression work to say the 5th term is AR to the n minus 1. So it's AR to the 4. So that's going to be 15. It's this 1.0855 to the power of 4 here. And then see what that comes out to be. And that comes out to be 20.8 kilometers so far. Right, so even with this question, so it's number 10. It's going to be a difficult question here. Don't give up on it. I think you can definitely get some of those marks, if not all of them. I think part A is easier than part B as we're going through and doing it. And what they're doing is they're trying to attack your confidence at doing something like this. This is the whole point about going through doing past papers, so that you get used to just saying, oh, wow, would I have been able to do that? If this was your actual exam, would you be able to do it? Well, doing this style of question is going to at least get you used to it a little bit. Part C may well be beyond some of you, but we'll go through and have a look at it now. And again, at the end of an exam, when you might have other parts that you can go back to, think about how important it is to try and get these 5 marks. It's quite a complicated process. But for some of you, you'll be, yeah, no, I've got everything so far. Right, let's bring it on. Let's see what this next bit's going to be. So this is where the Wednesday bit comes in. It says Owen is going to either run plan A or he's going to run plan B, but also in the meantime, he's going to run the same distance every Wednesday. So he's going to run X, then X, then X, then X. So we know he'll have done 12X for the Wednesday plus whatever he does on the Sunday. So it says X is an integer. Okay, so X is going to be a whole number. The total distance that Owen will run on Sundays and Wednesdays combined is not going to exceed 360 kilometers. So if it doesn't exceed 360 kilometers, what's the maximum value of X he can have if he uses training plan A, or what's the maximum value of X he can use if he uses training plan B? So you might think, I don't know what I'm doing here, let's just give up. Don't do that. At least say, I'm trying to work out the total distance that he's travelled. So if you think about it, if you're trying to work out the total distance that he's travelled, we need a sum of all of those ones, and you can do that. You can do, even if you don't get the rest of it afterwards, you can say for C part 1, what I need to do is to find the sum of the 12 terms he's got on that arithmetic progression. So let's make a start with this. So as I'm doing this, I'm not 100% certain where I'm going with it, but I know that what I need to do is find the total for Sundays. So I'm explaining to the examiner what I'm doing. So we're using the arithmetic progression so far for this one. So this is C part 1. So C part 1. Let's find out how far he travels on the Sundays. So we've got that A was equal to 15. We've got that N was equal to 12. We've got that D was equal to 2. And I want to use this formula. Sn is n over 2. So I'm getting marks for this. 2a plus n minus 1d. I'm still not absolutely convinced I know the rest of it, but I can get these marks. So stick this in. 12 over 2. 2a, 2 lots of 15. Plus n minus 1 is 11 if n is 12. 11 times 2. Okay, just work that out. It works out to be 312 kilometers apparently. Yeah, so if we've got that, let's now work out what X is going to be. Well, what we've got is that the maximum distance, so now I need to understand what I'm doing for this bit. The maximum distance is 360, and I have to do 312 using that because that's given to me, my Sundays. So if I do 360, take away 312 and work out what that works out to be, that works out to be 48 kilometers. Okay, and if I've got 12 weeks to do that in, 48 divided by 12 means I've got 4 kilometers per week. Okay, so I've got 4 kilometers per week if I do it using that method there. Part 2, we've got exactly the same idea about trying to find the sum of n terms here, but this time I'm finding it with this scenario. What we're now saying is that, yeah, A starts off as being equal to 15 again, but this time R is equal to my 1.085. Now, even when I'm saying what I've said this so far, even when I'm saying 1.085, I'm going to put my entire term that I had for R in. It was 1.08544 apparently, but I'll leave it as that as R. And I want to know for n equals 12 what the sum of n terms is. So the sum of n terms for this is going to be A R to the n minus 1 over R minus 1. So Sn is going to be 15, 1.085 to the 11 minus 1 all over 11 minus 1. But again, use as accurate a value as you can put in there. You're going to be multiplying to the power of 11, so you want to keep it as accurate as you can possibly be with that one. Apparently, if we do that, that works out to be 294.185 as we're looking at it. So once we've got that value then, we're going to say, okay, going exactly back to this thing here, let's do 360. So for B, let's do 360 minus 294.185. That's what that works out to be. All divided by 12. So that works out to be equal to 5.4 this time. So we get x equals 4 and we get x equals 5.4 as my two possible values. For training model A, just to summarize this, for training model A, x has to be less than or equal to 4. And for training model B, x has to be less than or equal to 5. So x is actually 4 and x is actually 5 because they're integers. Okay, hopefully that last bit makes sense. And certainly what we should be learning from this is even if you didn't get the absolute 4 and 5 parts to it, there's marks for doing that and there's marks for doing that. And I really want you to be focusing on, did you give up on it? Would you have been able to at least do those bits if you don't fully understand the very last bit? Okay, that's the end of the paper, end of that question. Hopefully that will make sense. And it's Christmas Day today, so Merry Christmas, everyone, if you celebrate.